Hello, George Romanic here. In my previous video, I introduced this problem. In that video, we also solved part A using equation of state. But now we want to find exact number of nitrogen, oxygen and argon molecules or atoms that escaped, not just the total amount of air. Let's start. So in part A of this problem, we saw that the total number of atoms that escaped this tank after opening and then closing it at 150 atmospheres is this huge number, 1.6 times 10 to power 32. But now the question is, how many nitrogen atoms escaped, how many oxygen atoms escaped, and how many argon atoms escaped? Well, we know that this total number, delta n, that escaped needs to be delta n of nitrogen atoms, N2, plus delta n of oxygen atoms or molecules, plus delta n of argon. Now I will divide this expression by delta n total to get that this is 1 equals delta n for nitrogen divided by total delta n plus delta n for oxygen divided by total delta n and plus delta n for argon divided by total delta n. But we know composition of air. If you don't know, watch my previous videos. We know that this over here is 78% of air. Percentage of, namely, nitrogen, N2, in volume of air is 78%. Relative percentage of oxygen in a volume of air is about 21%. And relative percentage of argon in a volume of air is less than 1%, but here we assume it's 1%. So you can see then from here that delta n for N2 divided by delta n is simply equal 0.78. Or from here I can therefore write that delta n for N2 is equal 0.78 times delta n. But delta n, I calculated it here in the previous video, so I multiply this number by 0.78 and I get that delta n for N2 is equal 1.32 times 10 to power 32 atoms. Similarly, I can write that delta n for O2, oxygen, divided by delta n is equal 0.21, 21%. So I get that delta n for O2 is therefore equal, well, 0.21 times this number, and I get that this is 3.31 times 10 to power 31 atoms. And lastly, delta n for argon atoms by total delta n is equal 1%, that would be 0.01, or I get that delta n for argon atoms is equal 1.58 times 10 to power 30 atoms. In next video, we are going to tackle part C of this problem, and that's to find the total reduction of the mass of this tank once the air leaked out. It's very instructional video, very interesting calculation, and I will see you there. Until then, goodbye.